Welcome to the channel RIK Learner for JEE Mains and Advanced. A particle having mass m and positive charge q whirls along vertical circle of a radius r. At the center of the circle, another positive charge 2q is present. And we are having four options. The minimum velocity given at the lowest point to complete vertical circular motion is less than root 5gr for motion in gravity. For any value of velocity given in horizontal direction at the lowest point in gravity free space, it will perform vertical circular motion. Option C. Tension in gravity free space cannot become zero at any point during motion. And option D. If the charge at the center is removed and considering the motion in gravity, tension will also be function of charge on particle. Well, so it's a vertical circular motion. So I simply write first a circle assuming whose radius is r. Okay, let us believe this is the circle. Of course, quite difficult here with this software to have the circle. Let it be. See, this is the circle if we assume, and here is the center with charge 2q. Okay, so another charge is moving around this charge, and that particular charge anywhere on this perimeter of the circle. Let me assume at the lowest point, which is here. Okay, the charge is here. So this charge is plus q, and this is also plus q, and whose mass is m. Okay, therefore, what should happen to the mass of the center charge? It should be 2m. The mass should be 2m because you know the charge, a single charge having the mass m, and the double charge should have the mass 2m, right? So now I assume two different positions. One is the lowest position, and another one is the highest position, which is somewhere here. Okay, so here I call this position as A and this position as B, right? See, one more thing I should say here, the particle is assumed moving in counterclockwise direction with the velocity VA at this point, and here the velocity will be VB, right? The velocity will be VB in this direction. So the particle now moves in a counterclockwise direction, right? So this is how the particle is revolving. Now I simply take two situations. One is at A and another one is at B. So initially, let me say at A. Okay, so at A. So what the equations that I can write here at A, the forces on plus Q. Okay, forces on plus Q will be these things. One is the gravity as usual in gravity space. Okay, so it is mg, and one more is the electrostatic repulsive force, because this charge is positive and this one is also positive. There must be repulsion between the two, right? So how much it should be? It should be k. K is electrostatic constant, that is 1 by 4 pi epsilon mu. Otherwise I simply write it k, and since the one charge is 2q and another charge is q, the force must be what? It is 2q divided by the radius, which is r. It is r square, and it should be multiplied by k, and again it should be multiplied by q. So this will be 2kq square divided by r square, right? This will be the repulsive force between the two. So now I write that kind of force here, that is 2k q square divided by r square. This is the repulsive force. And one more force that you can observe at A. Okay, so at A, what's happening? The gravitational pull from this plus 2q is also here because it's having a mass 2m. So there will be an attractive inward force, and that inward force that I can write here, this is the gravitational force, which is g into 2m, right? So how we can write? It is g into, it is 2m and m divided by r square, right? So this simply becomes what? It is 2gm square divided by r square. That is what I can write. 2gm square divided by r square. This is what that happens at a. Further, I can rewrite the result. The centrifugal force, centripetal force should exist in order to complete the circular motion, right? So, if particle Q makes no, circular motion, so then what should happen? Then there exists a centripetal. There exists, right? There exists centripetal force. Centripetal force on it, right? Force on it. It should exist. So how much it should be? So that force should be, right? So that will be the inward force. Okay. So that centripetal force will be the inward force. So inward force will act in this direction, right? So upward here in the picture we can say the centripetal force will act in this direction. Centripetal force, right? That will be the net force. Therefore, centripetal force that is equal to what I can write? I can write it is 2g m square divided by r square minus what it should be? It should be minus mg minus 2k q square divided by r square. Okay. Here the gravitational force will act like tension. Let me mark it here. So this one, this force, gravitational force, gravitational force acts like tension, right? So tension. Therefore, what I can write further, centripetal force will be what it should be. It should be m mass of the particle which is revolving VA square. Why I'm taking a VA? VA will be the velocity here, right? So I already written here. So VA square divided by radius, that is R. So that is equal to, it is 2 gm square divided by r square minus mg minus 2kq square divided by r square, and I call this equation 1. This is the result what we got at A. Right. So now we have to think about B, which is here. Right. So at B. So be careful here what happens. Now the particle plus Q, after making a half rotation, it will come at this point B, right? So now we have to think about that situation uh, at B. Now I'm thinking at B. So at B, what happens here is the particle and which is just moving to the left with a velocity VA. All right. So here the gravitational force is acting downward, which is always mg, right? So and one more thing is what? So one more thing is the gravitational attraction between the two particles, that is 2gm square divided by r square, and the repulsive force that is acting here, and that is 2kq square divided by r square. So now be careful. At B means the particle is at the highest point here. So here the centripetal force is acting downward, right? So centripetal force is acting downward. So what I should write now? So centripetal force must be is equals. It is downward means here, right? In the downward direction, the centripetal force must act. Here, what I can write is be careful when you are writing here. So this should be which is 2g m square divided by r square, right? Minus mg, right? No, it should be plus mg minus 2kq square divided by r square. 2 inward force and 1 outward force. 2 inward force will add up and 1 outward force is subtracted. So centripetal force is again written as mv, but here it's a vb. It should be b, right? So vb square divided by r. So that is equal to, it is 2gm square divided by r square plus mg minus 2k q square divided by r square. So this will be the result, and I call this equation 2. Again, you just observe this one will act like tension, act like right. So it's actually act like tension. Well, so further, what we have to do is we have to think about the energy. Okay, so let us write something about the energy here at A with respect to this line. Okay, so with respect to this line, the potential energy is 0 plus how much is the kinetic energy? That will be half mva square, right? So now when the particle comes to here after making half revolution here, so what I can write? I can write the potential energy with respect to this. Okay, with respect to position A, this will be it is m, right? G and h is nothing but this one, the height above which it is now. So which will be how much? It is r and r, right? So r and r, it is 2r. So that can be written like this one, right? This is a gravitational force and plus half m vb square. So this will be the kinetic energy. So now I can equate these two relations because we apply conservation of law of energy. It's an undisturbed system. So here in the conservative field, the two energies must be equal. So now we rewrite it here. In this one, I can simply write it is a 0 plus what? It is a half m va square, which is here, and here what it should be. So it should be here. It should be. It is a 2m gr plus half mvb square, right? So these two things. So this is the energy, total energy will be this much here, and here is also this much. These two total energies are equal, right? So now equating those two, so energy equating total energy. So total energy is at a and b, right? At a and b, what I can write? I can simply write it is 2m gr plus half mvb square, which is equal to 0 plus half m va square, right? So when I solve for a vb square, so for that I simply multiply by what I should be, it should be multiplied by 2 by m. Okay, so when I do that, so what I get this is 4gr plus vb square, right? So that is equal to va square. So vb square should be is equal to what? It is va square minus 4gr. So use this result. Okay, so use this result in any of the equation, but I use equation 2. Okay, so it will gives me some result. Okay, well, so now use this, in equation 2. So what happens here? So equation 2 is this one, vb square divided by r, m by r vb square. So m divided by r into vb square. Vb square is what? Actually va square minus 4g r. This is vb square, which is equal to what we are having in equation 2. In equation 2, I am having 2gm square, right? 2gm square divided by r, which is tension, Okay, so which is simply tension at B plus mg, that also written, right? So this is tension and this is mg, this is tension at B, right? Plus mg minus 2kq square divided by r square, right? Minus 2kq square divided by r square, right? So this is what I got, and now again multiply by r divided by m. So when I do that, I simply get a VA square minus 4 GR, which is equals, it is a R divided by M into TB plus it is a RG minus 2KQ square divided by R into M. This is what I got. And finally, VA square is equal to R divided by M into TB plus 5RG. When I bring this 4RG on this side, it becomes 5RG minus 2K Q square divided by R M. See, this is what I got. And now note about something that is TB. So this is the tension at B, right? So tension at B. So to complete a revolution, tension at B should not be 0. Okay, so tension at B should not be 0. Therefore, what it should be? It should be TA square must be more than 5 GR or RG. So minus 2KQ square divided by RM. This is what I can write. So now, here just observe, I am subtracting something from 5GR, right? So subtracting something from 5GR, yeah. So definitely what I can write now is VA square is less than 5GR, right? So VA square must be less than 5GR. Therefore, what I can write, VA is less than root of 5GR. This is one important result what I got here to choose one of the best choice, right? VA is less than root 5GR. This is the minimum velocity. Is the minimum velocity. Minimum velocity. Which one? VA is the minimum velocity at A. A is the bottom point, right? So now observe the option. The minimum velocity given at the lowest point, which is A. In our situation, it is A. To complete vertical circular motion is less than root of 5GR. This is what we got. So definitely this option is right. Now I have to think about B. For any value of velocity given in horizontal direction at the lowest point in gravity free space, it will perform vertical circular motion. Okay. So whatever the velocity you give at the lowest point, that is A, right? So the particle will move a circular motion, right? In gravity free space. It's most important. It is said it is in gravity free space. Well, what we have to bother? We have to now bother about equation 2. In equation 2, what we have to do is I simply assume there is no gravity free. That means from the earth. Okay. So further, I assume one main thing. Assume G, small letter G is equals 0. So care should be taken that capital G is not 0, right? So it's a constant. E is a constant, universal gravitational constant, right? So this is not a 0. We are simply taking small letter G is 0. If this is the situation, what happens in equation 2? In equation 2, I can simply say that in equation 2, where is equation 2? Equation 2 is here in this equation. What we have to do here? Now we have to think about such a situation that if this is 0, right? This is 0, and this whole thing is tension, which is TB, right? TB. So now what we have to think is, so if this is 0, right? So take this one is 0. So make this is 0 equal to 0. So what I get? mVb square divided by R, right? mVb square divided by R is equals tension plus 0 minus 2kq square divided by R square. So this is TB, right? So this is TB. If you give any velocity, right? So this one, you can give any velocity. So you can bring this one here. Okay, so now TB is equal to what? TB is equal to mVb square divided by R, right? Then what I can write? I can put plus 2kq square divided by R square. And be careful about this step. Here, this is a constant for a circle, constant for a circle, right? Let it be. If VB is not equal to 0, then TB is not equal to 0. So which implies forms a circular motion. A circular motion. If TB is not equal to 0, it forms a circular motion. So definitely in gravity's free space, for any value of the velocity given the horizontal direction at the lowest point in gravity free space, that means G is equals 0, right? It will perform vertical circular motion. So this comes right. So option A is right, option B is also right. See about option C. Tension in a gravity free space cannot become 0 at any point during motion. Okay, so take about the two equations, equations 1 and equation 2. So here in equation 1, what I already said, this point, that is this one is the tension, right? This is the tension Ta, right? So tension Ta. So if you make it 0, right? Make 0, make 0, this one. So what you may get? You may get mVa square divided by R square is equals Ta minus 2kq square divided by R square. So definitely it also makes a circle, as we already discussed in the previous part of the same question somewhere here, right? So now I can simply conclude that, so this forms a circle. That implies what I can write? I can write simply Ta is not equal to 0. This is the maximum possible tension. Okay, so maximum possible tension is not equal to 0. We already proved that TB, which is the minimum possible tension, this one is the minimum possible tension. This is also not equal to 0. So this concludes Ta is also not equal to 0. TB is also not equal to 0. This is a maximum, and this one is minimum. So both are not equal to 0. Therefore, nowhere you get, right, you get tension equal to 0, right? Tension equal to 0, even G is equal to 0, right? Even G is equals 0. So now I can simply say option C is also correct. D, if the charge at the center is removed, then considering the motion in gravity, tension will also be the function of charge on the particle. See this one here, what happens if you remove this one, the central charge, right? If you remove, if you remove plus 2q, So there exist or there will be no centripetal force, hence particle plus q would not make, so it will not make or makes, right, a circular motion, so it fails. So that means this option is wrong. Okay, so the conclusion is what, we got option A, option B and option C as correct choices.